In this session, we are going to look at more concepts, which is also known as stoichiometry. So let's begin. Under more concepts, the first thing we need to understand is what a mole is. So a mole is just the amount of substance equal to the Avogadro's constant. So we are saying a mole is the amount of substance equal to Avogadro's constant. So that is what a mole is all about. So from this definition, we're able to say 1 mole is equal to the Avogadro's constant. So in values, 1 mole is equal to the Avogadro's constant is 6.02 times 10 to the power 23. This could be atoms, this could be ions or molecules. So let's say you've been asked to calculate the number of moles in, let's say, in aluminium of, maybe this aluminium has 2.0 times 10 times 10 to the power 24 atoms. So how can you calculate the number of moles? You just use this proportionality ratio, which is 1 mole is equal to 6.02 times 10 to the power 24. Since we are dealing with atoms, we're going to say atoms. Then the next thing here, we're going to say how many number of moles are equivalent 2.0 times 10 to the power 20. Okay, this should be 23, not 24. So it should be 23, 6.02 times 10 to the power 23 atoms. Now, how many moles are in 2.0 times 10 to the power 24 atoms of aluminium? So we put X here. Then we cross multiply. So what we are going to have is we're going to say X multiplied by 6.02 times 10 to the power 23 atoms to be equal to 1 mole multiplied by 2.0 times 10 to the power 24 atoms. Then you divide on both sides by 6.02 times 10 to the power 23. So to the power 23 atoms. Even this side we divide by 6.02 times 10 to the power 23 atoms. So this definitely will cancel out. So X will be equal to atoms and atoms will cancel out. So we're going to remain with 1 more times 2.0 times 10 to the power 24 divided by 6.02 times 10 to the power 23, that is giving us 3.3 moles. So now the number of moles in 2.0 times 10 to the power 23 atoms of aluminium are equivalent to 3.3 moles. So this is how you can find the answer. So from this definition, you can say that number of moles is equivalent to the number of particles over the particles in the Avogadro's constant, okay? Where n is just the number of particles and Na is the Avogadro's constant, okay? So Na, we are saying it's the Avogadro's constant, which is 6.02 times 10. So 6.02 times 10 to the power 23. And this could be atoms, this could be ions, or maybe molecules. So this is the first definition which we need to understand. Let's look at another definition. So we can say that a mole is also the amount of a gaseous substance that occupies 24 cubic decimeter. That is at room temperature and pressure, okay? So a mole is the amount of gas that occupies 24 cubic decimeter at room temperature and pressure. The key word is at room temperature and pressure. So at room temperature and pressure. So at room temperature and pressure, 1 mole is just equivalent to 24 cubic decimeter. Okay, this is very important for us to understand. So for this one, it just applies to gases. Let's say we want to find the number of moles. So we're going to say now number of moles will be equal to the volume over the molar volume. And we understand to say the molar volume at room temperature and pressure, the molar volume will be equal to 24 cubic decimeter. This is at room temperature and pressure. So this is how you can find the number of moles. Now to find the volume, when you're measuring a certain gas at room temperature and pressure, given the number of moles, you just make V the subject. So volume will be equal to the number of moles multiplied by the molar volume. Okay, so you can use this formula. Right, let's look at another definition. So you can also define a mole as the amount of a gaseous substance that a substance occupy, okay? A mole is the amount of a gas, the amount of the volume of a gas, or the amount of a gas, okay, let me say the amount of a volume a gas occupy at the volume, the amount of a volume of a gas occupy which is 22.4 cubic decimeter at standard temperature and pressure. So at standard temperature and pressure, we say 1 mole is equivalent to 22.4 cubic decimeter. So it is just the amount of the volume of a gas which it occupies, and it's equivalent to 22.4 cubic decimeter at standard temperature and pressure. We know that at standard temperature and pressure, these are the conditions which it must satisfy. So at standard temperature and pressure, the condition is that it should have a constant concentration. Okay, the concentration must be constant, and the temperature at standard temperature and pressure, the temperature is equivalent to 25. Okay, this is the room temperature. It is equivalent to 25 degrees Celsius or 298 Fahrenheit. So this is, and also the pressure must be 1 atmosphere. Okay, this is at standard temperature and pressure. So the pressure must be 1 atmosphere, the temperature must be 25 degrees Celsius or 298 Fahrenheit, and also the concentration must be constant for this volume to be measured at standard temperature and the pressure. So we are safe to use the same formula. Number of moles is equal to the volume over molar volume. But what is going to distinguish this from the previous definition which we looked at is that for this particular one, the molar volume won't be 24 cubic decimeter, but the molar volume for this one will be 22.4 cubic decimeter. So this will be the molar volume. So when you're told to calculate the volume, we're going to say a volume will be equal to number of moles times the molar volume, but this is at standard temperature and pressure. So at standard temperature and pressure. Okay, so this is what we need to understand. I would like us to define a mole also in a different way. So we can also say that a mole is just the amount of a substance that contains as many particles as there are in 12 grams of carbon-12 isotope. So we are saying a mole is the amount of substance that contains as many particles as they are in 12 grams of carbon-12 isotope. So what are we saying now? So from this definition, we are saying that 12 grams